All right, today we are doing Chapter 2, Section 1 in Pre-Calc, the power and radical functions. Today's date is today, and our objective, we're going to graph and analyze power functions, graph and analyze radical functions, and solve radical equations. All right, this first slide deals with end behavior. So the first thing I'm looking at is the degree. That is your highest exponent. So I'm going to be looking, is it even? Is it odd? The next thing I'm going to be looking at is the sign of the leading coefficient. Is it positive or is it negative? If it is positive and even, my end behavior is up, up. If it is positive and odd, it's down, up. If it's a negative leading coefficient with an even, it's down, down. And if it's negative with an odd coefficient, it's up, down. Those are ones that you'll want to memorize. And if you get ambitious, here is the math speak of it. As x approaches negative infinity, that just means the left-hand side, y is approaching infinity. It's going up. As x approaches infinity, that'd be the right-hand side, y approaches infinity. It's going up. So that's just a fancy way of saying it. So on this one, we want to graph and analyze each function, describe the domain and range, the intercepts, end behavior, continuity, and where the function is increasing or decreasing. So there is a lot going on here. Some of it I'll write down, some of it I'll probably just verbally be talking about, if I can get it out. You might want to pause on occasion and take a better look at it. So first of all, we have to graph it. And if I don't know what that graph looks like, you can always make a t-table. And I notice I have an x to the fourth. Well, I can put in negatives. I can put in 0, and I can put in positives. So my domain here is all real numbers. I can put anything into that equation. So my domain is all real numbers. I actually took a shortcut on the graphing. I put it into desmos.com and came up with a graph. And this is what the graph actually looks like. I'm going to get some of the other information from this. So I know my domain is all real numbers, said that multiple times. My range, that's what my output is, what my y's are. So in this case, I look, my lowest y value is 0. There's nothing happening in my negative y range. So my range is y is greater than or equal to 0. Okay? My intercepts, well, my x and my y-intercept is 0 because it's crossing at 0, 0. So my y-intercept is 0, my x-intercept is 0. My end behavior is up, up. It's continuous. The whole graph is continuous because I don't have to pick my pen up at all. And it is decreasing along here, and then it starts increasing right there. So if I wanted to write that down, which I'm going to, it is increasing where it's green, where x is greater than 0. And if I want to put that in function notation, it would be from 0 to positive infinity. And here, where it's decreasing, it's where x is less than 0. And if I want to put that in function or in interval notation, it's from negative infinity to 0. And I'm using parentheses because you can never quite reach negative infinity, and 0 is actually the turning point. So let's do another one. X, or f of x, equals negative x to the 7th. Well, I've got an odd degree, 7 is odd, and a negative leading coefficient. So right now, I'm thinking that my end behavior, well, you take a second to figure out what your end behavior is. It's either down, up, or up, down. If you said up, down, you are correct. So, and my domain is going to be all real numbers because I can put any value of x in there. I'm not limited. My range is also all real numbers because it's going up to infinity and down to infinity. So even though I'm not writing this down, this would be something that if they asked you on a homework or a test or quiz, you would have to write it down. Domain is all real numbers. Range is all real numbers. Your intercepts are at x equals 0 and at y equals 0 because it's going through the origin. Your end behavior is up, down. It is increasing right here where x is greater than 0. It is decreasing from x is less than 0 because that's where it would have like a negative slope. All right, if you've got an odd or an even index for a radical, your graph is going to look slightly different. For an even index, you're only going to have one part of the graph. And the reason for that is you can't have a negative underneath that radical. Here, on the red one, I can't put anything less than 5 in there because I'm going to get a negative underneath that radical, and it's going to be undefined. So on this one, my domain would have to be x is greater than 5, and that's why I'm only getting like half the graph. On the blue one, I've got an odd index of 3. That means I can put a positive or a negative in there underneath that radical. So here, my domain is all real numbers. So if you've got an even index, anything underneath the radical has to be positive. If you have an odd index, you can have positive and negatives underneath the radical, because you can take a cube root of a negative number. The cube root of negative 27 is negative 3. The square root doesn't work like that. So that's something that you might want to make a note of in as you're taking notes. So on this one, same type of problem. However, we've got a radical. And again, if you didn't have a graphing calculator or an app in front of you, you'd have to make a t-table, which is not a big deal. You know how to plug things into an equation, or you should. We're going to describe the domain, range, intercepts, end behavior, continuity, and where the function is increasing or decreasing. So there's a lot going on in this problem. So here's my graph. And it makes sense that it is kind of almost like half a parabola, because my domain is x is greater than or equal to 0. And all I do is take what's underneath that radical and set it greater than or equal to 0 and solve. You can also look on that graph and know, hey, my lowest x point is 0 and everything after that is positive, which is what I'm doing on my range. My lowest y value is 0 and then everything is positive. So my range is y is greater than or equal to 0. My intercepts, x equals 0, y equals 0. Here, my end behavior, I would just, because we don't really have a left-hand side, it's starting at 0, 0. I would say as x goes to infinity, y goes to infinity. So we're only describing one side of the end behavior. As x goes to infinity, y goes to infinity. going to say that again for my end behavior. We're only describing one side. So as x goes to infinity, y goes to infinity. Continuity, there are no points of discontinuity in this graph. And there's no places where it's decreasing, it's only increasing. Think of that as it has a positive slope, and it's increasing at x is greater than or equal to 0. Why don't you take a second, graph this one on your own, and let's see how you did. Hit pause. When you think you have the answer, hit the play button, and let's go over it. All right. First thing I notice is it looks like I have a discontinuity right there. X cannot equal 0. Looks like I'm going to have an asymptote there. And the reason is that x to the negative 5 is going to be down in the denominator. It's also going to have an asymptote on the y-axis. It looks like it's touching, but it's just getting really close, so it doesn't look like y is going to equal 0. So my domain is all real numbers except x is not 0. My range is all real numbers. Y is not 0. There is a discontinuity at x equals 0. And I do not have any intercepts. All right, on this one, we are going to take a second and solve this one. We have 2x equals radical 100 minus 12x minus 2. Well, what we need to do is get that radical by itself. So I'm going to add 2 to both sides. Now that we have that radical by itself, we're going to square both sides to get rid of that square root. Because a square and a square root are inverses of each other, they're going to cancel each other out. And I'm going to be not over here on the left-hand side. Make sure you FOIL. That's 2x plus 2 times 2x plus 2. So now I've got a quadratic. Quadratics need to be set equal to 0. So I'm going to add 12x to both sides. I'm going to subtract 100 from both sides. I'll say that again. Subtract 100 from both sides. So that's where the negative 96 comes from. Add 12x to both sides. That's where the 20x comes from. We can go ahead and factor it right now, but I noticed, hey, that looks like it would be a hard factor, and I have a GCF. Pull out that GCF. Now factor. Set each factor equal to 0. And I've got x equals negative 8 and x equals 3. You want to plug those back in. But if I plug in negative 8, it doesn't work out. So I'm only going to have one solution there, 3. Whenever you're solving for a radical, you need to go ahead and check your answers. Because you can create what we call extraneous solutions. You didn't do anything mathematically wrong. You just created an extra solution. And our extra solution that we created was negative 8. All right, go ahead, hit pause, try this one on your own, and let's see how you did. All right, well, what I notice is you got a cube root and a cube. Those are going to cancel each other out. So you get x minus 5 plus 14 equals 50. This is a really easy problem now. Combine those like terms. X plus 9 equals 50. X is going to equal 41. That's it. That was super easy. That's all I have for you today. Hope you enjoyed.